And the day has finally arrived that we put all the stuff that we've learned and put all together, and now we curve sketch. So let's do a quick refresher of the things that we have covered already. So we covered curve properties and symmetry. There's even symmetry, and even symmetry means that f at negative x is equal to f at x. We know that we can have odd symmetry, which is f of negative x is equal to negative f of x. We can have neither when neither of those cases happens. In order to find asymptotes, we can have vertical or horizontal. To find the vertical asymptotes, we set the denominator equal to 0. That's the fastest way. And horizontal asymptotes, the fastest way is to take the limit as x approaches infinity. To find the axes-intercepts, we know to find the x-intercept, we set y equal to 0 and solve for x. To find the y-intercept, we set x equal to 0 and solve for y. In the first derivative, in order to find the critical points and the intervals of increasing or decreasing, we find where the derivative is equal to 0, and then we make a sign diagram. And then if we want to find our points of inflection and our concavity, points of inflection is second derivative is equal to 0. And then again, we put another sign diagram together. When we put all of that information together, we get something like this, where we can figure out where the maximum and minimum are. We can talk about the changes in concavity. This small chart basically says exactly what I've just said above. It's just another way to show it. So recognize that both I and the IB and the Ontario and whoever else, doesn't matter, everybody has different ways of showing the same information. Your job is to be able to interpret it into a way that you can work with so that you can move forward. Let's try our first example. So it says here, sketch the following function. Here's my function. It's a cubic function. So the first thing I want to do is take the derivative. So f prime of x is equal to negative 3x squared plus 6x. I want to set it equal to 0 and factor. So negative 3x and then x minus 2. So I know that I have two zeros, and my two zeros are x equals 0 and x equals 2. Next comes my sign diagram. Remember, in chronological order. On the left-hand side, I write my factors. I pick some test points, and my test point, something less than 0, so positive and negative, something in between 0 and 2, so let's say 1, negative, and something bigger than 2, let's say 5, that's negative and positive. So this is negative, positive, and then negative. So this graph is going down, and then up, and then down again. I have a minimum at 0 something, and I have a maximum at 2 something. In order to find the somethings, remember I substitute back into the original. If I substitute in 0, I get out 5. If I substitute in 2, I get out 9. Now, we have the option right now of going directly to the graph and putting these pieces of information on the graph. So I'm going to do that, 0, 5, and 2, 9. So I'm going to scroll down. 0, 5 is right here. 2, 9, right here. Here's my amazing 2 points. So I have my 2 points. This is my minimum, and this is my maximum. I'm going to label them so that everything is very clear. Okay, and we're going to go back. Now, second derivative. So f double prime of x. I've got negative 6x plus 6. I set it equal to 0. I solve for x. In this case, I can say 6x is 6, so x is 1. Again, I draw my sign diagram. This time I only have 1 on it. On this side, I have my second derivative. I pick a number less than 1. 0 is a good number. This is positive. I pick a number bigger. It's negative. So this is concave up. and then concave down. And there is a point of inflection here at 1 something. Again, in order to find the something, I take the 1 and I substitute it into the original and I get out 7. So 1, 7 is my point of inflection. So 1, 5, 6, 7 here. So if I put together the information, look here, it is concave up, and then it is concave down. Everything follows exactly what I want it to. It looks exactly, so if I line up the two sign diagrams here, it exactly shows me what I want to see. So it is, I'm going to use a different color here. I'm going to use green. So it is going down and then up. So notice this is concave up already, and then we switch directions, and then it goes still a positive slope, but now it's curved downwards. So if I'm looking at this right here, I have a slope that is less than 0. I have a slope that is greater than 0, a slope that is still greater than 0, and I have a slope that's less than 0. Notice from here to here, it's concave up, and notice that from here to here, it's concave down. So my diagram shows exactly what I want it to show. So let's try another one here. I'm going to give you an opportunity to try this one, so pause the video, do everything, and then see if your answer follows with mine. Step 1, take the derivative. So 3x squared minus 6x minus 9. Set it equal to 0 and factor. So I'm going to take out a common factor of 3. And then I'm going to factor this into x minus 3 and x plus 1. So I know that I have two zeros where x is 3 and x is equal to negative 1. I'm going to make my sign diagram again. Negative 1 and 3. I have x minus 3 and I have x plus 1. Now, some of you may wonder, why am I not using this 3 that's here? Well, this 3 does not have a negative sign attached to it, nor does it have a variable attached to it. So it's just multiplying everything by a value of 3. So I could use it if I wanted to and make everything positive across the sign diagram, but I don't need to. Okay, pick a number less than negative 1, negative 2, negative 5, it doesn't matter, so negative and negative. Pick a number in between negative 1 and 3, let's choose 0, negative and positive. Let's choose a number bigger than 3, so let's say 5, positive and positive. So this is positive, negative, positive. This is going up, then down, then up again. So I have a maximum at negative 1 something, and I have a minimum at 3 something. In order to find the somethings again, remember I substitute back in. So I get into the original and I get negative 1, 10 and 3, negative 22. So again, by habit, I'm going to put this right onto the diagram right now. So negative 1, 10 is here. And 3, negative 22 is here. So this is my minimum at 3, negative 22, and this is my maximum. My maximum is at negative 1, 10. Okay, step 2, second derivative. So f double prime of x is equal to 6x minus 6. Set it equal to 0. Solve for x. X is 1. Draw my sign diagram again. This is 1, 6x minus 6. Pick a number less than 1. Let's try 0. So negative. A number bigger than 1, positive. Concave down, and then concave up. there is a point of inflection at 1 something. Sub in the 1 into the original to get the something, which is at -6. So 1, -6 is right here. This is my POI. All right. So again, if I look at my two sign diagrams, it looks like it's concave down and then concave up. So that's great. So concave down, point of inflection, change directions, and then concave up. Perfect. I want you to give this one a go. This one is a little bit more challenging. I want you to try it first, then come back and check your work, see how you do. Unlike the last two examples, this question is not just one polynomial. This is a division of polynomials, so a polynomial over a polynomial. Hopefully you'll notice right away that I have something relating to the domain here. It says x cannot be 3. That is an asymptote. So I know that there is a vertical asymptote here at x equals 3. So I'm gonna draw that in right away. I'm going to draw it in with a hashed line. I'm going to say x equals 3. That is the asymptote. Now I'm going to see if I have a horizontal asymptote. So I'm going to take the limit as x approaches infinity, and I notice that I have a horizontal asymptote at y equals 1. So I'm going to draw that in as well, and I'm going to label that y equals 1. So even before I've done any real calculus work, I already know that I have two asymptotes, and I know that I'm going to have a little bit of work here that is in only 2 of the quadrants that I've created with these new asymptotes. So I'm going to have something probably here and here, or I could have something here and here, or I could have something here and here, or I could have something here and here. So it's not likely that I'm going to have it one on top of the other, but I am going to have some sort of diagram that I know. All right. So let us take our first derivative. Ideally here, the quickest one to use would be the quotient rule. So I'm going to take the derivative using the quotient rule. And my quotient rule says down, d up, minus up, d down, all over, down, down. There it is. I'm going to simplify a little bit. When I simplify, I get x minus 3 minus x minus 2 all over x minus 3 squared, which is -5 over x minus 3 squared. Now, look at my numerator. My numerator is just -5. There's no variable there. And if I look at my denominator is x minus 3 squared. So here's the funny thing. It's the same denominator of that 3, but I already know that that 3 is going to cause me a problem. That 3 is going to have an asymptote at it. I have a -5 and I have an x minus 3 squared. Well, let's look at the negative number, -5. Negative times whatever is still going to be negative. And if I take a number and I square it, that number is always going to be positive. So it doesn't matter what number I put in there. So this is both going to be negative before the 3 and after the 3. So it's going down and then down again. Well, let's look at our diagram here. How can I go down and continue to go down without actually ever hitting an asymptote? So let's just think for a second here. If it's going down and I start drawing here like this, I've hit an asymptote. That's a problem. And if I try drawing like this, again, I hit the asymptote, so that's a problem. So I've got to think about a way of going down and then down again.